All right, hey grade 11s, welcome back. Last lesson, woohoo! All right, we're so close to done this unit. Good job, you guys. Hopefully you're with me so far, and if not, you let me know. And I will chat with you on Teams to help you get caught up. Okay, so this last lesson, we're going to be talking about interpreting graphs, okay? So that is, in my opinion, well, at least in my experience, people really like doing this, so hopefully you find that the same. And we're going to use all of the skills that we know, so all the things about slope and how to read a graph and all those things, to talk about faster or slower rates of change, and that sort of thing. Usually the graphs that we're going to look at are going to kind of tell a story, and we're going to want to figure out pieces of that story. So, pardon me, I did include this graph here, okay, and it's just like a helpful graph. It just has a bunch of kind of tips or whatever you want to call it to talk about distance time graphs, which we're going to talk about today. So when you see a distance time graph, when you see a straight line like this, or this, that means that the person or the object in the question is moving at a steady speed, okay, so that's really important. And then if you see a curved line like this or like this, then that means that the speed is not steady. And when it's going up like this, that means something is getting faster. And when something is going down like this, it's slowing down, okay? We are going to mostly look at straight lines, but just so you know, this is a good reference point, okay? All right, let's move down here and start the first example. Okay, Colin leaves his house at 11 a.m. for a bike ride with his dad. The graph below displays his movement. Use it to answer following questions. All right, so the first thing we know already, without even having to do any work, is that this is 11 a.m. here, right? He starts at 11 a.m. To go for his bike ride. And so the minutes that pass, this is like 5 minutes after 11, 10 minutes after 11, quarter after 11, and so on, okay? And so that actually is going to help us answer question A, because we know that if we start at 11 and the bike ride has been 25 minutes, then he is going to get home at 11:25 a.m. Perfect. That's so messy. I'm sorry, you guys. I really hate this stylus, as you probably can tell. Good enough. Okay. Then when is Colin going the fastest on his ride? So remember that going the fastest means the highest rate of change, right? And when we talk about rate of change, we're talking about slope, okay? So we're talking about when is the slope the steepest. Sheesh. Okay, there you go, steepest slope. So, if you ask me, this portion here looks like it has the steepest slope. And so because of that, then I can say that Colin is going the fastest on his ride from here to here, right? So he is going the fastest from, what time is that? 11:08 to 11:12. Okay, there we go. That's the answer to that question. All right, let's go to the next page again, because, sorry, I couldn't make them all fit on one page, but that's okay. So if we look at the next page, we're saying what is happening between 11:12 and 11:15. So I want to know what's happening in this time. So that's up here. Okay, so if you take a look here, we can see that the distance is not changing while the time does, right? So what happens when somebody's distance is not changing when the time is changing? So it means that they're just standing still, or they're remaining in the same spot, right, as time goes on. So we can say that Cohen and his dad are stopped at this time. Okay. Wow, that's so messy. Let's try that again. There we go. Stopped. Much better. Okay. Well, except for the D. Not much better. There we go. Okay, so they're not moving, and that's because his distance is not changing while the time does change. Okay. Okay. Sorry, I had to get a little bit of water. Okay, question D. What does it mean when the graph has a positive? That's supposed to say A, not as. Whoops. Okay, let's correct that. A positive slope. and what does it mean when it has a negative slope. So if we go back and look, remember that a positive slope means going up and to the right, and a decreasing or negative slope means going down and to the right. Okay, so we're looking at both of those sections. So if you take a look again at the axes here, we can see that as we're going up and to the right, so both of those two sections, that means that the distance is increasing, right? So that means that Cohen is biking a further distance, right? So that means he's going away from home in the positive slope time. Okay, so positive slope, Cohen is biking further from home. Okay, and then the same logic, but the opposite when it's the decreasing slope, right? So we can see that still the distance is changing, but this time it's going down back to 0, right? So his distance is decreasing, which means he's going back home. So he's biking towards home. Okay, and describe each portion of Cohen's bike ride. We've essentially done that, so I'm just going to put all of the information together, okay? So Cohen bikes away from home. But I'm not going to end my sentence there, because if you go back and look, we can see that his rate of change increases, right? So we first have a shallow line here, and then it gets steeper. And so that means his rate of change, or the speed he's cycling, is changing. So Cohen bikes away from home slowly, and then more quickly. Then, the middle portion there that we talked about, Cohen stops for 3 minutes. Then, or last, I guess we could say, let's say that's better, Cohen turns around, right, because then he goes back home. That's what we talked about just here, biking towards home. Cohen turns around to bike home at a constant speed. And the way that I know that, again, let's go back and look at the graph, is that we can see that the slope does not change this whole time, right? He just goes home at a constant rate. Okay, so there, oh dear. There we go. Okay, there we go. Let's look at the last graph. This is our last example of the unit. Woo. Okay, so we are looking this time at a very different type of example. We're looking at the time of day compared to the number of cans in a vending machine. Okay, wow, I don't know why that erased. Okay, so we are going to take a look at how many cans are in the vending machine at any given time during the school day. I really like the screen, you guys. I always try and write with it. Okay, so describe what is happening in the vending machine between 12:30 and 1 p.m. So we can see that 12:30 is here and 1 p.m. is here. And look at that. This like skyrocketed, hey? And so what we can deduce then is if the number of cans went from 100 all the way up to 400 in that short amount of time, is the vending machine is getting refilled. There we go. Okay, calculate the slope between 7:30 a.m. and 10. Okay, so I tried to highlight this and make this a little bit of like a brighter red on my computer in that section because we're going to be working with it. So you can see from 7:30 to 10 is the section that we're looking at, okay? And so we can see that at 7:30, which is where this first red point is, to 10, which is where the second red point is, we have a decreasing slope. So we know already that our slope should be negative, okay? So that's like a little hint we can give to ourselves. So let's use rise over run and see if our theory is correct. So remember that rise is the vertical change and run is the horizontal change. So we can see that the rise is just here, right? It goes down. It's not very super neat and tidy. There we go. It goes down from, what does that look like? 250 down to 225, right? So we go down 25 cans, okay? I'm going to just erase a few of those marks There we go. Okay. And we can see, so that's that run, and then we can see that, so that's the rise, and now here's the run, okay? We're going across from 7:30 to 10 a.m., so that is 2.5 hours, okay? And so the reason that's positive is because we went from left to right, like how we read, okay? And then if you do that division in your calculators, we're going to get negative 10. And that means essentially that the number of cans is going down by 10 per hour. Okay. All right, let's talk about this here. What might be happening between 10 and 10:30 at school? So here's 10 and here's 10:30. So we can see that the amount of cans is going down much more quickly during that time, right? And so what might be happening then is that more kids are buying cans of soda, and so we can guess that there might be a break in classes because more cans are being bought, or many more cans, actually, like a lot more cans. Okay, so why do we think the vending machine gets refilled between 12:30 and 1? Well, 12:30, let's think about what time that is at school. That's lunch hour, right? 12:35 for us, I guess, but close enough. I'm going to say because it's lunch hour, so lots of people want to buy cans of soda or buy soda. Okay, and then the last question here says, sorry, I guess I should show it to you first. Explain why the graph changes at 7:30 a.m. So let's take a look here. And we can see that there is no change right until 7:30, okay? So what do you think is happening? If there's no change in the amount of cans between 7:30 and 6 a.m., so from 6 to 7:30 in the morning, why that might be the case? Well, in my opinion, my theory would be that the school's probably not open until 7:30, right? So that's so bad. Oh my goodness, there we go. The school is closed before 7:30. So the first cans sold will have to be after 7:30, right? Okay, there we go. I just want to add one more thing to B before we finish off here. So this means that there are 10 cans sold per hour. I realized that I said that, but I didn't actually write it, so there we go. Just want to fill that in for you. Okay, and so there we go. That's it. That is the last example in our notes. Okay, so we're all done. I know this is blank page. I just left it if I needed any extra room, but we're actually all done. So there's our interpreting graphs. If you have any questions about this, let me know. And again, I will get some sort of worksheet up there for you guys in the next little bit. Okay, message me if you have any questions, but otherwise, congratulations. We're done our unit. Good for you guys. And I will be putting some sort of hand-in assignment up on our Teams page relatively soon. So just heads up for that and keep an eye out. Okay, talk to you guys later. Bye.